uh, represent this. I'll tell you. One second. Yeah, you can represent this reaction as x a comma x a comma b y. Okay, which means that when you incident x with a, you get the the products y and b. So Y is necessarily going to be a heavy nucleus, okay, and B and A are going to be light nuclei, okay. So they are also nuclei, but they are light nuclei. So I hope you understood this representation of a nuclear reaction in the form of this X bracket A comma B Y. Have you understood this, students?
Yes, sir.
Okay. So now let us look at some of the examples. Okay. So if we talk about alpha decay, what happens in alpha decay? Emission of what gets emitted in alpha decay? There's an emission of an alpha.
I'm sorry to interrupt, sir, but your voice is really not clear.
It is not clear.
No,
Hmm.
sir.
So I'll do one thing. I'll change my position. Actually, I'm sitting very far from the. Okay, let me see. Let me try to connect my hotspot. Wait a second. I'm sitting far away from the router because my kids are naughty. They'll not let me sit in one place. Okay, so let me. So I'll connect with my hotspot and I'll ask you one second. One second. So you can see the screen, and we have been discussing about these nuclear excitations. And after that, we are discussing about nuclear processes, of which we have talked about natural processes like radioactivity, fission, and fusion. So I think fission and fusion directly come under nuclear processes, whereas within radioactivity, you have these processes alpha decay, beta decay, and gamma decay. Okay. Now I am clear. Okay. Once again, I will be asking. Now my sound is clear. Thumbs up, I cannot, unfortunately, because I'm sharing the screen. If you are doing a thumbs up, I'll unable to, I will not be able to see. Yeah. So you have to tell me if my voice is clear. No, you have to tell me clearly.
No, sir.
My voice is not clear.
Sir, are
No,
you
sir.
using a headphone?
I'm not using a headphone.
Sir,
What?
I think you are moving your mouth or speaking to a little bit closer to some moments and a little bit far away from the mic, so that that's why your voice is not as smooth as we would like.
So, okay. So let us do one thing. Can we have some way of? Let me also join the through the what is it through my phone. Maybe my because my laptop was dropped some time back. So my laptop's earphone, maybe laptop's mic is not working properly. Let me see. I'll join through the phone also, so that my audio will come through the phone. Will that be okay? Let us check that. Let me check. So it's after a long time that once again we are doing this online, and that is One second. Students, am I students?
Yes, sir.
Am I audible now?
Yes, sir.
Yes, sir.
Okay. So good. So this is better that I can see your thumbs on the phone. Okay. So so now I hope you are able to listen me clearly, and you are talking about these natural radioactive processes in which you have alpha decay, beta decay, and gamma decay. In alpha decay, you have alpha particles, which is helium nuclei that are emitted, and there are beta decay processes where you have electrons or positrons being emitted. Okay, or you also have, in beta decay process, you also have electron processes like electron capture. Have you heard of electron capture?
Yes, sir.
Okay, so can you tell me what happens in a electron capture? Can anyone tell what happens in an electron capture? I think all of you are very much aware of alpha decay, beta decay, and gamma decay. I don't have to tell you. Yes or no?
Yes, sir.
Uh, so in electron capture, what happens is that uh, an electron is captured by the nucleus, so that the nucleus gets transmuted. So what happens in beta decay in general is that there are creation of isobars. You remember what isobars are? Isobars are nuclei having similar A. The A value is same for isobars, right? So what happens is that it is natural to expect that in a beta decay process, the nucleon number is conserved. Okay, the total number of nucleons stays the same. A remains the same. Okay, what happens is the conversion of either a neutron into a proton or the creation of a proton into a neutron. You can see my screen, right?
No, sir.
Ah, that was the mistake I made. Let me see. You have to tell me. I forgot to share my screen. Now you'll be able to see. So you are seeing my screen now?
Yes, sir.
So here you can see that I have written beta. Below beta, I have written electron, positron, and electron capture. You can see it, right? And below electron capture, I have written isobars. Okay, so in the beta decay process, what happens is that there is creation of isobars, which means that in beta decay process, a nuclear species gets converted to another nuclear species by while keeping the total number of nucleons constant, यानी कि A constant रह जाता है, ठीक है? तो यानी कि उसमें क्या होता है? N plus P remains same. So either a neutron gets converted into a proton or a proton gets converted to a neutron. This is the basic thing that happens in beta decay. So you can see because charge conservation would be applied. You have a neutron here. Let us say this is the first thing that I'm talking about. You have a neutron here. A neutron is electrically neutral, and then you have the proton, which is electrically charged. It means that to balance this, I'll have to write an electron over here. Okay, students, you agree with me? So a neutron gets converted into a proton with the emission of an electron. So this is what beta minus decay. This is called beta minus decay. On the other hand, it can also happen that a proton can get converted into a neutron with the emission of a positron. Okay, there can be emission of a positron, E plus. Okay, so this is example of a beta plus decay. Okay, so this is beta plus decay, this is minus decay. So what happens in beta minus? Electron is emitted, beta plus positron is emitted. Okay, so you have to just remember, basically you don't have to remember too much, you only remember that in beta process what happens, conversion of या तो न्यूट्रॉन प्रोटॉन में कन्वर्ट हो जाता है या प्रोटॉन जो है न्यूट्रॉन में कन्वर्ट हो जाता है. अब किस प्रोसेस में क्या एमिट होता है वो आप चार्ज बैलेंस करके कर लो, है ना, बिकॉज कंजर्वेशन ऑफ चार्ज is a basic fundamental conservation, okay, which has to be obeyed by nuclear processes also. Okay, so what are the things that need to be conserved in? So you must have already studied a few things about conservation laws in nuclear and in particle physics. Have you studied conservation laws?
No, sir, not yet.
Not yet. So there are quantities like charge, spin, parity, energy, momentum. So these are the quantities in general that have to be conserved. Okay, charge, spin, parity, momentum, energy. So these are the things. So conservation of energy, you are very much aware. Conservation of energy, conservation of momentum in mechanical systems. Similarly, here also in the nuclear regime, energy has to be anyway conserved. Momentum also has to be conserved. When I say momentum, naturally it includes angular momentum and linear momentum also. Okay, these are some of the quantities that need to be conserved in nuclear process. Let us come back to the beta decay. So this is what this part I am discussing about beta decay. So these are the two beta decay processes. Just I'm trying to tell you that you have to just remember regarding beta decay that a neutron is either converted into a proton or a proton gets converted into a neutron. You can find out which particle is emitted just by using charge conservation. Okay, so I hope you have understood this. Apart from this, there can be what? there can be electron capture. So how would electron capture look like? Electron capture would be the capture of an electron by a nucleus, and that electron gets interacts with a proton and resulting in the formation of a neutron. Okay. Okay. So can you tell me, students, which of these processes is a spontaneous process? यानी कि आप कुछ नहीं करो और ये spontaneously हो जाएगा. From the equations that I have written on the right hand side of the screen, can you tell me which one is a spontaneous process? Just to, prick your curiosity. इन तीनों में से कौन सा, though I have given hints to you that if you keep things in mind, you will be able to immediately tell. Yes or no? Can you tell me? I can see your thumbs up, thumbs down also now. Can you tell me which one
Beta minus decay.
is going to be a spontaneous process? Hardik was speaking. Who was speaking?
Yes, sir. Beta minus decay.
So can you give the reason? Can anyone give the reason? Hardik can answer it, but I want somebody else also to. Can anyone tell why neutron to proton is going to be a spontaneous process? No idea? So what decides whether a given reaction will take place? कोई reaction होगा या नहीं होगा? इसको कैसे decide करेंगे? How nature decides? Nature decides by the Q value. Can you see that I have written Q? Q value of reactions. All nuclear reactions have a certain Q value. So what is meant by Q value? This is also a general thing that we will we'll have to keep in mind while this is a very easy thing, not a very tough thing. Q value is nothing but you have, as I said, you have the reactants A plus X. So you have A plus X giving you Y plus B. So how do you decide this reaction takes place or not? You just look at the masses of the reactants. Okay, so you calculate the masses of the reactants, you calculate the masses of the products. So what you'll get? You'll get a mass defect. What is the mass defect? Difference in masses of. So if you have mass of A, so mass of Y minus mass of, sorry, not minus, mass of B minus, so this is the mass of the react products minus minus mass of the products. So mass of the reactants, which is mass of A plus mass of X. Okay. So when you do Q is equal to delta MC square, you obtain the Q value of a given reaction. Okay. So if Q value is positive, it means that that reaction is spontaneously possible. But if Q is negative, it indicates that there must be, at least there must be that, let us say, Q positive means it should be spontaneous. Not always, but yes. Okay, we'll talk about the exceptions also. Okay, so Q is not the only requirement, but yeah, it is one of the basic requirements that Q has to be positive. So then the process, if Q is positive, the process is spontaneous. It can take place. But if Q is negative, then what will happen? It cannot take place. There has to be a certain threshold energy that has to be, okay, that has to be provided. Unless you provide that much amount of energy, that reaction will not take place. Okay, just like chemistry. Okay, a little bit similarities here with chemistry. So in chemistry also you do this exothermic reaction, endothermic reaction. Okay, you have a certain activation energy that you provide for the reaction to take place, right? It's very much similar to those things in chemistry. So it is the Q value. So now if we come back and look at this equation, first one, neutron to proton, which one is heavier, students? Neutron or a proton?
Neutron.
Neutron, sir.
Neutron is heavier. So since neutron is heavier and electron, is so if you look at this reaction, first one that I have written here in beta decay. So the first reaction is what? Neutron getting converted into a proton and an electron. So a neutron, since it is heavier, it means that if I calculate the Q for this reaction, Q is going to be positive, right? So if you leave a neutron just like that, right? So if for example, let us say you have already studied statistical mechanics, right? So if you talk about, so you in statistical mechanics, you have studied about electron gas, photon gas, right? Do you remember, students? Do you remember electron gas, photon gas? You don't remember? Okay. So
Sir, can you repeat the
if
question?
you I was asking that have you heard of the neutron? You have heard of photon gas, electron gas in statistical mechanics?
Yes, sir,
स्टैटिस्टिकल
we
मैकेनिक्स
have.
आप लोग पढ़े हैं ना तो उसमें फोटोन
Yes, sir.
गैस
We have heard
इलेक्ट्रॉन
about
गैस
that.
हाँ सो अच्छा फिशन रिएक्टर जो होता है न्यूक्लियर रिएक्टर उसमें कौन सा पार्टिकल्स को यूज करते हैं फॉर टू इनिशिएट और कंट्रोल द रिएक्शन
Slow moving neutrons.
slow moving neutrons. What is the other word that you use for the neutrons, for such slow neutrons? You also call them thermal neutrons. Okay. So this neutron, no, this is one difficulty with the neutron. So if the conditions are not good, then a neutron will always try to, spontaneously convert into a proton, which means that neutrons are not stable particles. Okay. Neutrons are not stable particles, as stable as protons. Proton जो है उसको आप independent रख लो वो for example you can have a gas of what are protons? Protons are just hydrogen nucleus. So you can have a gas of protons, but if you have a gas of neutrons, they'll have a certain lifetime. They'll always tend to get converted into protons. You can do your own reading on that, but this is what happens with neutrons. This is very interesting that neutrons, unlike protons, are not stable particles. They'll always tend to convert into uh, protons, okay, but with the emission of an electron. So I hope you have understood that. So okay, so we were talking about these isobars, which is a characteristic of what the beta decay process. So in the beta decay process, you have creation of isobars. The next thing that we'll study in detail is the alpha decay. So I'm not talking too much about the alpha decay. We'll anyway discuss it. You keep one thing in mind that the alpha decay is associated with nuclei. If you remember the chart of nuclear stability, right? So you saw that the beta decay is the most prevalent type of decay. कहाँ पे बीटा decay होता था? Low atomic number, high atomic number कहाँ पे होता था बीटा decay? Do you remember it?
High atomic number, sir.
बीटा decay कहाँ पे होता था?
High
बीटा
atomic
decay
number, sir.
Lower,
मतलब बीटा decay कहाँ पे होता है? फिर से देख लीजिए, सोच लीजिए. हाँ.
low atomic number, sir.
Low atomic numbers, right? So it is not even just restricted to the lower atomic numbers, but you see that you remember the line of nuclear stability, the black line, which was bending towards the which axis? You had the chart of
X-axis,
nuclear. The x-axis में क्या था plotted?
atomic number.
Z, atomic number.
You had no. I think it was an NZ plot, right? And it was bending like this, right? So more neutrons are preferred. Why does it bend? That line of nuclear stability. You have to remember, students. I keep on reminding you. You should remember it. ऐसे ही था ना? It was N versus Z.
Yes, sir.
Okay.
Yes,
अब
sir.
ये N की तरफ क्यों bend हो गया? The line of nuclear stability. Because adding more protons to a nucleus will do what? Increase the
Electrostatic repulsion.
Coulomb repulsion. कूलम रिपल्शन बढ़ जाएगा. Okay, but what binds the nucleus? It's the
Nuclear
nuclear
force.
cohesion या nuclear force, which is what short ranged. Okay, which is largely similar between NP. It's not exactly similar. I have to tell you. NP, PP. What is PP, NP? ये हम क्या लिख रहे हैं?
Neutron, proton.
न्यूट्रॉन प्रोटॉन 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 और न्यूट्रॉन न्यूट्रॉन के
Proton,
बीच में जो
neutron,
न्यूक्लियर
neutron.
फोर्स है ना, इट्स ऑफ द सेम ऑर्डर ऑफ मैग्नीट्यूड. ठीक है. तो इफ यू वांट द न्यूक्लियस to remain stable, then we will have to do what? After a certain point, you have to add more neutrons. Okay, so you cannot just have equal number of neutrons and protons. Agar right, that you see in the periodic table also, when you look at the atomic masses and the atomic numbers, atomic masses जो है हमेशा 2z नहीं होता है ना, 2z से थोड़ा ज्यादा होता है. हमेशा atomic number जो है a जो है 2z से ज्यादा होता है. क्यों ज्यादा होता है? Just to compensate for the coulombic repulsion. So I hope you have understood this. So that is the reason why more neutrons are preferred, and that is why your line of nuclear stability is bending towards the x-axis, yani ki neutron axis. Okay, that is how you remember it. And now, if you remember about beta decay, the beta decay was the most prevalent thing. It is everywhere. You have one kind of beta decay on. Let me see. Okay, so on this side, so yellow line represents the line of nuclear stability. The green line uh, represents nuclides that have higher number of neutrons. Okay, they have higher number of neutrons. so so on either sides, what will particles are what? What happened? Are you able to hear me, students?
Yes,
Yes,
sir.
Yes, sir,
sir.
we are able to hear you.
So on either sides you have what? So on one side you have so let me talk about the green region. The green region is the represents those nucleides that have higher number of neutrons. So यहाँ पे neutron excess है. On the other side you have what? Proton excess. तो अभी जैसा आपको बताया था कि बीटा डीके प्रोसेस में if you have excess protons, those excess protons will try to get converted into neutrons, right? So when you come close to the line of nuclear stability, you have a preferred value of n comma z. ठीक है? So अगर n ज्यादा है या z ज्यादा है, in both ways it's like a parabola. We'll discuss it when we are discussing. It's like a parabola. So on one side you have neutron excess, on one side you have proton excess, right? And here in the center, you have the line of nuclear stability, which is going into the plane of the paper, something like that you can think. So you are looking at the cross section, energetic cross section of this image that I have made. ये जो red, yellow, green जो है ना, उसको ऐसा वो if you look at the energies, then it will look like a parabola. We'll derive those equations also. So it will look like a parabola. So if you have a proton axis, all the protons will get converted slowly in steps into neutrons, and it will come to the bottom of this parabola where the nuclear species will be stable, and it would correspond, this lowest point on the parabola would represent the line of nuclear stability. Similarly, vice versa on the other side, if you have neutron excess. So neutron excess जब है तो क्या हो रहा है? Neutrons, what do you see here? I'll just mark here. What do you see here, students? Here, what is that? So what is this? The red circled part, neutron getting converted into a proton, is what? Which decay? Beta plus or beta minus?
Beta
Beta
minus.
minor.
Beta minus
So it
decay.
means that the green region that I have here corresponds to neutrons getting converted into protons, which means that the green region that I have here is representing what? Which decay? Beta minus or beta plus?
Beta
Big.
minus.
Beta minus. Good. So you have beta minus decay here and you have beta plus decay here. Okay. So now alpha decay is happening somewhere over here. You look at the chart of nuclear stability, you will understand. Alpha decay is a characteristic of heavy nuclides that have atomic mass greater than 150 or 150. Okay, so if A is greater than 150 in the region of 150, then those nuclides prefer to do what they prefer to get rid of some of their extra nucleons, because it's just like a liquid drop. If you know that making a small drop is easier compared to a very large drop, or even if you have blown bubbles, you know that smaller bubbles are easier and more stable. They won't break easily, they'll fly for a longer distance. But if you have made a very big bubble, very easily it will give these oscillations. थोड़ा सा भी turbulence होगा air में, they'll immediately break. But the spherical bubbles, the smaller bubbles will be spherical. They'll not show so much oscillations. Similar, some parallels are there with the nuclei also. I hope you have understood this. Okay. So बहुत बड़ा हो जाता है, then what happens? If the nucleus becomes too big, then uh, if the nucleus becomes too big, then there is what? There are these oscillations, there are these excitations that can take into that can come into the picture, making the nucleus more unstable. So I hope you have understood up to this point. If you have any questions up to this point, you can ask. Any questions, students?
No, sir.
No? Prem does not have any questions. Others, could you understand whatever was discussed?
Yes, sir.
Okay. So I'll also give you some numericals that you can solve. I'll also give you a notes for your alpha decay. You can go through those notes and be prepared. And meanwhile, you can also try to solve some of the numericals that I'll be giving. Okay. So I hope we did not go much further. Some of the time was lost in making adjustments because this was the first day. I don't want to burden you with more information. But if you have doubts, I encourage you to ask. Now you tell me how I can take the attendance.
Excuse me, sir. Am I audible?
Yeah, you are audible, Vishnu.
Sir, there is an extension in Meet where you can take the attendance. It does automatically.
Where is that? I have to install that or what?
Sir, if you allow, I'll share a video with you.
Video.
Yes, sir. I have recorded video when you were doing some technical difficulties. I recorded a video how to install that extension.
How to install that? So आज के लिए हो जाएगा, तुरंत install हो जाएगा वो?
सर
और if you
मेरे में किया गया था तो वो थोड़े लेट से था, तो आई एम नॉट श्योर कि वो सारा अटेंडेंस लिया होगा कि नहीं, बट रिपोर्ट है मेरे पास.
तो ऐसा करते हैं, वो वीडियो हम देख लेंगे अभी. हाँ, उसको कल के क्लास के लिए या नेक्स्ट जो क्लास होगा, अब क्या करेंगे ना, क्लास जो है अपने रूटीन के हिसाब से ही ले लेंगे.
ओके सर.
ठीक है, इज दैट विल दैट बी ओके स्टूडेंट्स?
यस सर.
रूटीन में मेरा जब क्लास है, या आपको लग रहा है कि जैसे राजेश सर का क्लास सिलेबस कंप्लीट हो गया क्या आप लोगों का?
No,
न्यूक्लियर
sir.
का, सॉरी पार्टिकल का नहीं हुआ है ना? तो शेड्यूल के हिसाब से आप लोग ही रिमाइंड कर देना मेरे को दैट देयर इज अ क्लास, जस्ट वन डे बिफोर, so that I can take the class.
Yes, sir.
Okay, according to the schedule, I'll be also prepared. But by chance, in different things, if I I forget about it, then you remind me. I'll take a class because your exams may be when? Do you have any idea?
22nd of July.
23.
27th
23,
of
sir.
23 or
22nd of July.
23rd of July.
So what I was thinking is one way that we directly start after the vacation, but that way what will happen? No, some part will get accumulated. अभी हम लोग छुट्टियों में कुछ कुछ धीरे धीरे ही सही, कुछ कुछ आगे अगर हम लोग बढ़ जाएंगे तो रीओपन होने के बाद जो बर्डन है ना वो कम हो जाएगा. ओके, दिस इज व्हाट आई एम थिंकिंग.
Yes, sir.
Okay, so what I'll try to do, can I, so don't leave now, attendance is important. हाँ, आप लोग का
Sir,
50 people I
sir,
can
you
see
can do
है.
one thing, sir.
हाँ, tell me.
Sir, you can do one thing, sir. You can call one by one all numbers, and they will say yes, sir, and you can write them out.
Sir, we
कोई
can
दिक्कत.
write our name and roll number in the chat also.
You can write your roll number in the chat also.
Yes, sir,
Let
in the
me
Google
stop
Meet
share.
itself.
So let me see. Let me change the mode of tiles. कैसे change करते हैं ये जो screen का ये जो appearance या change layout. Spotlight. So almost all of you are present. 50 से ऊपर हैं क्या? How many people are there?
50 plus, sir.
50 plus है. ठीक है. I think most of you are there. 1, 2, 3, 4, 5, 6, 7, 8. 8, 3 8s are 24. 3 8s 24. बाकी लोग कैसे आएंगे? 23 are there. Okay, let me. Okay, 30 others are there. Okay, so 50 लोग तो शायद नहीं आ पाएंगे ना. अच्छा 52. Okay, okay, including me. So I am logged through two devices. No, my mic is on.
Yes, sir.
Yes, sir, your mic
हाँ
is
हाँ.
on, sir.
Okay. 1 second. Just hold on. Class हो गया है. बस attendance थोड़ा ले लें. Then I'll have